I've been having way too much fun playing with little mini PCs. Some of you guys might have seen my video last week where I looked at the 780M based, this is the BeeLink GTR7 Pro mini PC, actually beating the trusty old GTX 1066GB in some games. It certainly wasn't an overall win, but it was surprisingly close in a lot and even did score some victories. In this video, we're going to be adding in two more mini PCs to the mix. Both of these are from Minisforum. One of them is the older 690 UM690 system, which is based on a 6900HX APU that has a Radeon 680M, which is the predecessor to this RDNA 3 GPU. This is the RDNA 2 based version. And then also the UM790 from Minisforum, which is comes with the same system as in our GTR7 Pro, which is the 7940HS with the 780M inside of it. But there's another big difference here. So in this video, we're going to get to see a couple of things. One is a direct comparison between the 680M based previous generation and the 780M based next generation between two extremely similar mini PCs. That'll be a nice direct comparison. But there's something else going on here. These two were shipped to me as 16GB systems. Now, in a mini PC like this, these integrated GPUs share memory with between the GPU and the CPU. So even if you feel like 16GB is great for gaming at the types of games that you'd be playing on these PCs and the types of settings, you're like, that's not going to be that big of a deal. Remember, you're having to share the VRAM and system RAM, together from that pool. Whereas the GTR7 Pro I was shipped from BeeLink came with 32GB equipped. And that, I think, is going to be making a big difference. Also, I believe when we're looking at these, well, these are about as close as we could get. At least these are the three mini PCs I have. These are very close. I do believe that we have DDR5 4800 memory in the older 680M based system. And I think it's upgraded to DDR5 5600 in the newer 780M based system. So that's going to make a difference. So memory speeds and memory capacity definitely make a difference here. And that's a lot of what we're going to be looking at. In my last video, again, we looked at, the GTR7 Pro. So again, this is a 7940HS based system. A lot like the Minisforum we're adding into the test here. The difference is, again, though, that this one, for one thing, it is bigger. Did I show you guys that? These are not the same size. So the Minisforum certainly is more of a mini, even minier mini PC. They're about the same height, but one of them is definitely bigger. Anyway, so again, we're looking at, this isn't really just Minisforum versus BeeLink, though, because in my BeeLink video, a lot of people said, yeah, but you could buy a bare bones kit and put in faster memory, and that might be even more of an advantage. Well, I can't test that here, but I am going to mention the UM790 Pro does look like you can get it a lot cheaper as a bare bones system, and then add in your own SSD and RAM. And a lot of what I'm going to look at in this video is, should you definitely go for 32GB instead of 16, the way they shipped it to me? Because I do feel like that was a problem. And then also, I can't test this directly, but because they're using the system RAM as VRAM, because these are APUs, going with the fastest RAM you possibly can would be sure to pay off. Anyway, let's jump into some benchmarks where we can look at, again, two very similar systems for looking at the 680M performance versus 780M performance. And our first test will only feature these two. But then for most of the testing, we'll also throw in the 32GB GTR7 Pro to look at how much of a difference having that extra system memory is making. Let's hop into the benchmarks and I'll give you some final thoughts at the end. My first test is Unreal Engine 5. This is the game Layers of Fear, which is our first Unreal Engine 5 game at low settings with upscaling. TSR quality is upscaling from 1080p. At launch, this game's FSR implementation didn't seem to be working, and at these settings, the 780M is 15% faster and almost averaging, mid-50s, although we certainly dip below that on the 780M. If we turn off the upscaling, now the 780M is ahead by 13% on averages, and definitely does lose a bit of performance, but still very, very playable here at native 1080p low settings. Now, I do want to admit that this is not the most demanding Unreal Engine 5 game, and also, wait, where's my BeeLink 32GB system? This game came out right after I tested that system, and before I put this video together, so this was really just kind of an extra bonus. Hey, you get to see it in Unreal Engine 5. Anyway, if we go up to 1080p medium settings at native 1080p, we certainly see the 680M dipping below 30 FPS a lot more often than the 780M does, and we still see a 13% lead on the 780M, but a 21% lead in the 1% lows. And what if we, again, upscale a little bit with TSR quality? TSR is the upscaler. It's very similar to FSR and built into Unreal Engine 5. Here, we're getting a 19% lead for the 780M and a 20% lead in the 1% lows. And, you know, we are averaging over 40 on the 780M. They're both pretty playable here. Again, I don't think this is going to be the most demanding Unreal Engine 5 game. And if we do kick it up to the high settings, the GPUs do really show that they're going to have some trouble with that. So more demanding Unreal Engine 5 games and settings, I think, will definitely give it some trouble. Here we're seeing them both down in the 20s. The 780M does have a 13% lead on the averages and an 18% in the 1% lows. Not particularly playable, but what if we upscale a bit here? So using TSR at the quality setting, they're both still going to dip below 30 FPS at times, but this does get them a lot closer to a 30 FPS average, especially on the 780M, which is 14% faster in this test. Although, weirdly, I'm seeing some stutters on the 780M, leading to it actually losing in the 1% lows. Now let's jump into the rest of the testing, where we will also see the BeeLink system with 32 gigabytes of RAM. And we'll start out with Call of Duty Modern Warfare 2 at 1080p basic settings. But this is full 1080p resolution. And here, I think we're definitely seeing the 32 gigabytes paying off, it seems like. And we're seeing a 34% lead for the 780M with 32 gigabytes over the 680M. And the 16 gigabyte system kind of splits the difference. And if you look at the 1% lows, there's a much bigger advantage for the 780M systems, especially what I'm seeing on the BeeLink. Now, if we enable FSR2 quality, which is now like a 720p internal resolution that's being temporarily upscaled up to a 1080p output, all the systems, including the 680M, average over 60 FPS, but the BeeLink over there on the right is 33% ahead, and the 780M Minisforum PC is 21% ahead of the 680M. All of them giving very playable experiences here, but I don't see as many of the little stutters on the frame time graph with the 32 gigabyte system. If we go down to FSR2 performance, this is now, I think, something like 360p internally, something like that. So it doesn't look amazing, although the frame rates are actually fairly competitive here, especially on the 32 gigabyte system, where once again the 1% lows, ahead by 65%. It's making a very big difference here, not seeing the stutters on the frame time graph or any of that. So all of them putting up a pretty good showing here, but I think it's definitely paying off to have the extra system memory, it seems like. Now, what if we jump up to a more graphically demanding single-player game like Cyberpunk 2077? Can it play Cyberpunk? Well, at 1080p medium settings, the 680M is under a 30 FPS average, but the 780M systems are over 30 FPS average. But the 32 gigabytes of system RAM certainly seems to be helping the 1% lows and the averages, giving it significantly more of a boost. Again, 33% over the 680M versus 19% over the 680M and 47% in the 1% lows. So much bigger deal there. Now, again, what about using some upscaling? If we use FSR2 quality to upscale from a 720p internal resolution, now all of them are giving really a very playable experience. Even the 680M. And the 780M with 16 gigabytes is 11% faster, and with 32 gigabytes, we're 29% faster and 38% faster in the 1% lows compared to the 680M-based system. The 780M with the 32 gigabytes here, I think if you did also want to set a frame rate cap with the better 1% lows, it would be a lot more consistent of an experience. But what if we don't need to play at the medium settings? What if we were willing to go down to the low settings? Well, here we actually are seeing all of them averaging over 30 FPS, but once again, the 1% lows, especially on the 680M based system here, can give a little bit more trouble. And we're seeing the 780M with 32 gigabytes of RAM almost doubling the frame rate in the 1% lows versus the 680M based system. But again, similar results overall with the 16 gigabyte 780M 11% faster than the 680M, and with 32 gigabytes, we're seeing 29% faster. Now we're looking at Forza Horizon 5 1080p low settings, and all of the GPUs are delivering, Mini PCs are delivering a really excellent experience here. The 680M is still averaging well over 60 and going up into the 70 FPS range, but does have its 1% lows below 60. The 780M based systems are averaging into the upper 70s or even low 80s on the 32 gigabyte GTR7 Pro. So it's a 13% lead and 19% lead respectively for the 780M based systems. Notice that we're not seeing as large of a gap in the 16 gigabyte versus 32 gigabyte system there at the low settings, and even moving up to the medium settings, we're not seeing as big of a gap here as we saw in some of the other games. So I think it just really depends on how much memory those games are using. I think at least is affecting our results here. And again, though, at 1080p medium settings, they're all doing very well. Even the 680M is almost averaging 60 FPS, with the 780M with 32 gigabytes around 69, and the 780M with 16 gigabytes around 67 FPS. So they were doing so well, I actually cranked it up to the high settings to see what would happen here. And at the high settings, we're still seeing them averaging, well, the 780M based systems are now averaging around 60, and the 680M has fallen off. But the 780M based systems are performing very similarly here. The 16 gigabyte and 32 gigabyte are not making that big of a difference. You see a little more difference in the 1% lows, with a 24% lead over the 680M versus a 17% lead over the 680M. So it is still paying off to have that 32 gigabytes of system RAM, just not as much in this game as we've seen in some other games. Speaking of some other games, how about The Last of Us Part 1, which is a PS5 exclusive that's been ported to PC and has been very demanding on PCs. At 1080p medium settings, none of these are able to average 30 frames per second. Although we're certainly seeing, I think, the extra RAM on the 32 gigabyte system paying off in the 1% lows, where they are 32% ahead of the other systems, of the other 780M based system. And the 680M based system is technically a little ahead on the 1% lows, but it's by 1 frame per second. So I think that's just kind of them having about the same result. If we use FSR2 quality, we can now boost performance to a 30 FPS average on the 680M, and then into the mid-30s on the 780M based systems. It's a 13% lead for the 16 gigabyte system and a 20% for the 32 gigabyte based system, and in the 1% lows, it's 11% and 18% leads respectively. So again, looking like the upscaling is coming to save the day. Looks like you get a pretty decent 30 FPS experience there. However, if you'd like to play at native resolution, going down to 1080p low settings does seem to get our 680M to around a 30 FPS experience. And honestly, these results look very similar to the frame rates that we got at the medium settings using upscaling. So going down to low gets us similar results instead, but we get to keep the native 1080p resolution. Here we're not seeing a massive gain, I think, from having the 32 gigabytes, it's not split massively different between the two systems there, but did give a bit of an improvement, it seems like. Now, with low settings and enabling upscaling, so FSR2 quality, we're now actually getting a very, very playable experience on all of these. Playing in the 40s might not sound much better than in the 30s, but from an input response feeling, especially if you're using a mouse, not a controller, I think it actually does make a very big difference. Now all the 680M averaging around 40, the 780M 16 gigabyte around 44, and the 780M 32 gigabyte around 46. So let's try another really memory-heavy game, and we can definitely see it here at Resident Evil 4 Remake at 1080p balanced preset. We're going to see some stutters On the other system, on the 680M here that we're not seeing as much on the 780M based systems, and especially on the 32 gigabyte system, really pulling ahead in the 1% lows, 19% on averages and 27% on averages respectively for the 16 gigabyte and 32 gigabyte system. But the 780Ms were at least over 30 FPS average, whereas the 680M was not. If we enable FSR2 quality, we now get the 680M based system over 30 FPS, and the 780M based systems up closer to 40 and even into the 40s on the 32 gigabyte system here. Again, if you look at the 1% lows, though, especially the 32 gigabytes seems to be paying off, although both 780M based systems seem to be doing a lot better there than the 680M based system. Now, if we reduce graphics settings to 1080p prioritized performance, which would enable upscaling but on its own, but I've turned that off back to a native 1080p resolution first, and then we'll test some upscaling. We now see even the 680M averaging around 40 with 1% lows around 30. And then the other systems are pulling a bit ahead of that into the low 40s and then upper 40s on the 32 gigabyte based system. Now, if we do enable some FSR2 at the quality setting, we're now seeing all of them very, very playable here now, I think. The 680M is in the mid-40s. The 780M 16 gigabyte is in the upper 40s. And the 780M 32 gigabyte is now in the mid-50s. It's 23% ahead of the 680M, and then the 16 gigabyte system is 11% ahead of the 680M based system. Well, it certainly seemed like in some games, like Forza Horizon 5, there wasn't that big of a difference between the 16 gigabyte and the 32 gigabyte base system. It definitely also seemed like in some other games, there was a larger difference between the two, and it seemed like the 780M can definitely be held back on a 16 gigabyte based system. So that's certainly one of the main conclusions we can make from this video. The other conclusion we can make is there's really a lot of gaming performance available in these little mini PCs. Now, I'm not saying that these are the best value way to build a PC. I think you can still get better value out of just building a normal PC. But those can't just like clip onto the back of your monitor the way something like this can. These just work in situations where what you need is a tiny form factor with a surprising amount of power available. And especially if you're sticking to less demanding games than what I was testing here. We saw in less demanding stuff like Forza, we're doing great. If you're playing, older games, a lot of older esports titles, things like that, like not everybody's gonna be trying to play The Last of Us on a little mini PC. Although we saw that you certainly could, especially if you're willing to use a little bit of upscaling, things like that. So overall, I think you can get a pretty nice gaming experience on these things if you're interested in the mini form factor. Now, if form factor is your thing and you're comparing the BeeLink and the Minisforum PC, the Minisforum PC is definitely smaller than the GTR7 Pro. And again, while we saw the GTR7 Pro definitely taking the lead in these tests, remember that it had an advantage to how it was configured, and we should not ignore that. I think one thing to look at with the Minisforum PC is if you want to go that route, possibly going bare bones and grabbing and upgrading it yourself, that kind of a thing. Anyway, I'm, by the way, by no means an expert on mini PCs. I'm just getting these sent as review samples and had a huge amount of fun playing with them. None of these gave me any kind of problems during my testing. They all seem to run well. Again, I was surprised by how much gaming performance you do get out of these things. And again, you just, if a mini PC is what you're looking for, I think there's a surprising amount of performance there in general. Some more just kind of final thoughts, since I'm more interested in the actual just building a desktop PC kind of space. I'm really interested in what AMD could pull off in a desktop APU. These are really laptop-based stuff, being used as a little mini desktop PC. If they really pushed the power and packed in some more compute cores, I'm just wondering, like, what if we, how good could the APUs get, especially if we had a full desktop-based part and could feed a lot of power at it, that kind of thing. Anyway, what do you guys think about all this? Are you guys interested in a mini PC? I'll try to put links for this stuff down in the description if you are interested, and I hope all of you have an excellent day.